Right. So, my name is Nelly. I'm a program manager on the SQL Server team, and today I'm going to talk to you about how to build a predictive model and deploy it with R using SQL Server machine learning services. Before we start, I'm kind of curious. I want to know how many of you are R users today? Great. Saw some hands there. And how many of you would consider yourself like fluent in T-SQL? All right, a lot of SQL Server people. Great. And how many of you have ever used R services or machine learning services in SQL Server? Okay, a couple of hands there. Good, thank you. Gives me an idea of what type of audience it is. So let's start. Just to give you some background here, I have two different screenshots from the SQL Server setup. So if you want to use SQL Server machine learning services, or what we recently called R services, this is how you get it. So in the SQL Server setup, you basically pick, in the feature selection, you basically pick this feature, and that's how you will be able to work with it with the in-database machine learning capabilities. So in SQL Server 2016, see there to the left, you have the setup where we call this R services, and we very recently actually changed the name of it. So in SQL Server 2017 CTP2 setup, if you would go there, you would actually see machine learning services. It's the same thing. It's just that we added Python integration, so we could no longer call it R services, which is why it's now called machine learning services. So I just want to clarify this so that there's no confusion when you go and want to try this out on your own. All right, so in this session, I'm just going to walk through a demo of how you would actually, build a predictive model in R and how you would, put it inside SQL Server. Before we go into the demo and the actual, I want to give you some context. I'm actually going to tell you something about myself. I'm a huge ice cream fan. I love ice cream. Do we have any ice cream fans here? Good. So, on the side, when I'm not working for Microsoft, I have this ice cream shop. And it's called MS SQL Ice Cream. I know, it's a lovely name. And a while back, I came over this big batch of cotton candy flavored ice cream. It was cheap, so I bought a lot. So now I have a freezer full with cotton candy flavored ice cream. And I want to sell this. And I want to target customers that are likely to buy or like cotton candy flavor. And that's what the demo scenario is all about. So we basically want to predict which customers that are likely to buy this flavor, so that we can target them in a promotion email and hopefully sell more cotton candy flavor. So typically, when you want to build a predictive model and deploy it or operationalize it, as we say sometimes with SQL Server, there's a process that we recommend that you follow. And that's what we're going to do here. We're going to start in an R script, in an R development tool. And we're going to go through the script so that we're sure that it works, so that we're happy with our model. And once we've done that, then we can move it inside SQL Server. I'm telling you this because it's actually much easier to work this way, because the way that you execute the R script within SQL Server is that you put it inside a special stored procedure called SP execute external script. And that stored procedure takes the entire R script as a parameter, like a string. So sometimes it can be difficult to debug when you're in that mode. So basically, when you're happy with the script, then it's easier to move it and sort of do a very simple debugging inside SQL Server. And then in the same way, when you do your prediction, you just embed it inside this special stored procedure. And then your app can basically call the database and consume this data. It's pretty simple. So let's get started here. All right, so what I'm going to do now is that I'm going to go to my R script. I'm using R tools for Visual Studio. You can use any tool that you prefer to develop R. So what I'm going to do here now is that I'm just going to connect to the database, and I'm using a lot of the RevoScale-R functions. The RevoScale-R functions belong to a RevoScale-R package that comes with SQL Server, and it's part of Microsoft R. And the good thing about these functions is that it's very easy to read data from SQL Server using them. It's very easy. So you can use this, or you can use RODBC if you would like. There are different methods, but I prefer this. One of the reasons why I prefer this is that you can actually set a compute context with the Rx functions. And what does that mean? So typically when you execute R, let's say that you're in a client and you're executing towards the server, then you're basically reading the data into your memory. So your memory could be a limitation depending on how big your data is. And by putting the compute context like I'm doing here, and pushing it to SQL Server, I'm basically saying that all the compute that you're doing in the script, you should perform on the server itself. So it's not doing any, moving any data. And that data movement sort of saves me time. So let's execute this just to as I told you here, I have a query up here that's basically selecting my data. So I'm using these Rx functions to get my data. It's a very simple R script. We can import the data if we want. Now we're actually importing it into the memory. So take a look at it. So if I write, for example, let's look at the first rows of this ice cream data to see how it looks. This is my data. So if you look at my data, I've basically taken raw data and I've created features from it. And in data science, data scientists often talk about features and feature engineering. So I've basically taken the customer data that I have for this ice cream shop, and I made features out of it. For example, I have age, so I created an age group, different categories of ages. I also happen to have some survey data, but I surveyed some customers to see which people are like cotton candy, and they replied. Not everyone replied, but some of them replied. And I can use that data to train my model. I have some demographics, and I also have some historical data of what type of flavors they've purchased before. So for example, if someone has purchased 2 scoops of vanilla, I would classify them as they like vanilla. So basically, you engineer your features yourself, and the best people to engineer them are the people who understand the data, understand the business. So I've put together this in the feature table, and I basically want to show this to the model and say, learn from this. I want to train the model to say that, learn from this data, so next time when I'm going to show it new data, it will be able to tell me for a specific age group, for someone who likes, for example, vanilla, doesn't like chocolate, likes cookie dough and those things, is this person likely to like cotton candy? So that's basically how this works. So let's do the training. This problem, maybe I should have told you this, but this is a very common problem. This is called the binary classification problem. And with the binary classification problem, basically classify something as a yes or no, and you get a score. So you get a probability. That's the output from this. So you get a probability of a likelihood of something happening. Is this person going to like cotton candy flavor or not, for example? What is the likelihood? So to do a binary classification problem, you can use a logistical regression, create a logistical regression model that uses that algorithm. And that's what we're doing here. And we're using the RX logit, which means that it's just a logistical regression implementation in the Microsoft R. So it's whenever the function starts with Rx, it basically means that it is a RevoScale R function. You can use any other R function too, of course, and do the binary classification. So now we have a model object here. So if we want to take a look at this model object, they don't show you much, but it's just a bunch of information here in the model object, as you can see down here. So now, it's pretty simple. We're just going to use that model object, and we're going to call a function called rxpredict. If you don't want to use rxpredict, there is a function in R called predict. So you can use that instead. So now we're going to use the same data that we trained the model. Okay, let's see here. Oh, yeah, I missed a step. Sorry. This is actually an important step. Since I have the compute context to SQL Server, this means that I don't just perform everything in R. The stuff that I'm doing, it's on the server. So now I'm saying to this script that create a table in SQL Server, like a SQL Server data source, and call it prediction table. And take the predictions from here and put them in that table in the database. So that's what this is doing. It's basically outputting directly to that table in SQL Server. This doesn't happen if I have a local compute context. This only happens if the compute context is on SQL Server. So if we go to SQL Server here, and we do a selection of this prediction table that I just generated, these are the predictions that we got. As you can see here, we have a probability. So what we can say in the end is that we can say that anything above 0.6 is a yes, they like cotton candy, or anything below. That's sort of a limit that you decide yourself. You can decide yourself. But you can see here that this was the actual value, and these are the predicted values. And just looking at some of these, they seem to be pretty okay. This is like a 45% chance, and here it says a 0, doesn't like candy. Of course, you can do other type of analysis to sort of verify your model. We're just going to do it this way in the sample. So now, we worked in our R script. I have a warning here. It's because the version of R I'm running, so you can just disregard that. So we have our R script, and now we want to move this into SQL Server. And what we often say is that we want to operationalize it. Now we're happy with the script. Let's move this to SQL Server. And you might ask yourself, why should I move this inside SQL Server? Well, for one, it will be easier for any application to be able to access this. Two, you won't have to move any data anywhere. It's all in the server. And if your data is already in the database, this is the recommended way. And of course, if it's in SQL Server, you can leverage other things in SQL Server, like column store indexes. You can leverage in-memory tables and those type of technologies alongside the R script to sort of boost the performance. So if we're going to move into SQL Server, first of all, we will need somewhere where we can store our model object, right? Because in R, we were just working and everything was in memory when you're running your R script, or at least on your client machine, it's in your session. On SQL Server, we want to be able to store it. And a good advantage of this is that you can actually set up tables and do your model management that way. You can have different versions of models. You can have, if you have different data scientist teams working, you can sort of distinguish the models this way, in an easy way. So this table basically stores the model object that we have. Next, we want to do the training. So we're going to split our code that we just had into training and then prediction. So let's train our model here. I'm creating a stored procedure. I'm having a bunch of parameters here. For example, the input query that we had in the R script, I have here. I'm passing an R script. And just as I told you, as you can see, the R script is sort of just a string that we're passing as a parameter. So it's not highlighting any code or anything. So it can be a bit difficult to like code this way. And then we're making a call to this SB execute external script, which basically executes our R script for us. And then we're saving the model in the database. So let's do this now. I already have the stored procedure created, but let's truncate the table, empty the table, and generate a model. And then let's take a look at the model. It's really nothing to see. It's just a binary object in the database, as you can see there. Next, we want to use, so here's one thing I forgot to mention. So when you use the training and you have a data set, typically you split the data set. Let's say that you use 80% of it for training, and then you use the remaining 20% just to validate your predictions. So in this case, I'm using 20% of the data and performing a prediction on that with the model just to verify. And in a similar way, we have the R script here. And we're just going to use the model from the table and execute. So let's execute this prediction here. See what we get. All right. It's very similar to the table that I showed you before. It's basically giving us a probability. Now, the interesting thing is that we've showed it some data. We trained the model. Now we want to use it on new data. New data where we haven't classified if the customers like cotton candy flavor or not, or something else. So I have a very similar stored procedure here. It's just that the input parameter, the input data that I'm sending to it is some new data. And I want this procedure to basically tell me which ones like cotton candy flavor or not. So I'm doing a select statement here and just sending it to this stored procedure. And as you can see, there's nothing telling it if there's a likes cotton candy column or not. So it doesn't know. So let's execute this. What I'm getting back here is the username, basically the customer that I wanted, and a probability of them liking cotton candy. So now, for my promotion email, I can select the email addresses for these specific customers where the probability of them liking cotton candy is higher than 60%. That's what I hear. And for those, I basically want to send them to my app and send out a promotion email. Oh, I have to create my table first, of course. So I have my email addresses, and in this way, if my data already is in SQL Server, then I can just easily make this available to my application and send out the promotion. So there are some things that you can do inside SQL Server if you want to leverage, for example, parallelism. I had some parameters up here, for example, that I didn't use. And if you're running, for example, an R script when you're not using Rx functions at all, you can use this parameter to tell machine learning services that you want, wherever possible, for example, for the prediction, If the query is possible to run in parallel, you will do so. You want to do so. And similarly, we also have another parameter for streaming in cases where you have huge amounts of data, billions of rows. You can tell, with this parameter, you can tell it to basically process in batches. So it takes a chunk and then processes it and then the next chunk. So there are a bunch of parameters that you can play with to get a better performance doing this with machine learning services inside SQL Server. And I think that going back here, these are just the stored procedures that we just created. And if you thought this was interesting, you want to hear, going more in depth and hear more about machine learning services or machine learning, here are some related sessions that I recommend. I think most of these are tomorrow. They can take a look at. And also, if you want to get started on your own and walk through tutorials, I highly recommend, if you don't remember anything from this session, please remember this, aka.ms/mlsqldev. If you go to that link, we have created a website where you can look at some getting started tutorials for both R and Python in SQL Server and machine learning services. So please visit that. And this code will also be available on GitHub by the end of this week. Yeah. That's it. Yes. Sorry? Yes, absolutely. All right. Thank you.